or the day after, so that there's one less thing for you guys to stress about tomorrow. Oh yeah, Mr. Richmond's out of the office. So this is that one where you need the second derivative test for relative extrema. For those of you just joining us, the kiddos, the screen is frozen for the ones that are in class today. They're grading 2002 because you guys were trying 2 FRQs over the weekend. But here are the answers to 2000 letter A. You can go through and give yourself a check for each step you were able to get. And then here are the answers for letter B. Very pre-calish, looking at the logarithm. Domain U is greater than 0 for any logarithm, and then range, unless the range has been disrupted with an absolute value or something. It's like any log, forever low to forever high. But now they're here on 2002, grading letter A, using what we talked about in the slope field worksheet, that with a differential equation, relative extrema, you have to use the second derivative test. So even for the kiddos in class, plugging in, you had to find the second derivative first of all. And then plugging in the point, you figure out the second derivative is positive. So if the first derivative is 0, you have to show both. The first derivative is 0. For the justification, sadly, you have to show the first derivative is 0. It has to be a critical number. And the second derivative is greater than 0. You didn't have to write 1/2, but you did have to show that it was positive. Those 2 clues are enough to say relative min. There's an or. You did not have to write all of this. This was another way of proving it. Yeah. A little bit and use the test. The test was by far the preferred way. By far the preferred way. All right, let's go down to letter B, though. That's the one where you had to solve the differential equations. Let's see if you got those 6 points. So many points on just solving a differential equation. Did you separate the variables correctly? Did you take the antiderivatives correctly? Using the power rule. Using basically power rules again. Did you solve for y by multiplying by 2? Rooting. They did C first. Remember, you don't have to have their necessarily. That would have been fine. That would have been fine as well. But why, oh why, if solving for y gives you a plus or minus square root, why did they choose the negative? What was your clue? The y value was negative, yeah. If the y value was positive, it would have had to have been the positive square root. But since the y value is negative, they had to choose the negative square root. They had to think in context of the problem. All right, if you guys can, if you've been grading according to like the AP style, you can give yourself a score out of 9 on both of those FRQs. We're going to come back to questions on the FRQs, but our first priority, I think, is probably to get into the test review and see what questions you have. Now, really quickly, I want this class period to be productive. For those of you that came in late, just a quick heads up, I'm not going to be today, but period 7 and during lunch, I am. So come in, ask questions if there's anything we don't answer in class. But I have gone ahead and in Google Classroom posted the answer key. I'm in the FRQ test. We're going to talk about 2000, 2002 FRQs and if you have any clarifications that you need. And we're going to go over multiple choice questions to the practice test if you've had time to do it after we cover, our test review questions. So kiddos, here's our test review. This is the one that was due this morning at 7:45. Remember, there were 2 different pages. We did them on Friday as far as the review and the chapter. I think these are like AP practice or something. They were just great questions, great multiple choice practice. I think all the odds were in the back of the book, and then for this one, the AP practice, the odds and the evens were in the back of the book, so you could have graded all of them. So what do we have as far as test review questions? 23. What else, Patricia? 2, 5, and 9 for this section, right? What else do we have? AJ? 1, Ale?
7 and 19.
for the review part? Yeah. Anything else? On this one? 1, 2, 3. Okay. So we're going to camp out on the AP practice problems in just a second. If any of you guys need to, I do have extra books up here if you do need to come check this out if you didn't make it all the way through the test review. Remember, if you're bored, as always, you can be working on your practice test. Other questions, AJ? Okay, so we're pretty much doing that whole thing. And then Ale, 37 on the first one. Let's start then on the reviewish question and see what's going on. I'm not necessarily going to work through step by step by step by step. So it's going to be basically us figuring out. Sorry, guys. It's almost gone, but it's not quite all the way gone. Figuring out where you guys are stuck. So you're going to have to let me know as to where you've gotten. Oh, why is this not zooming? This is so sad. What's going on? That's okay. You guys have the questions either in front of you or stink. Man, guys, I'm sorry. I don't know why it's not zooming. Well, here, I can always do it the old-fashioned way. Oh, hi. There you go. Hopefully it focuses in. Does it focus? There you go. It's trying to. All right, we'll do it the old-fashioned way. 23 and 37 on this page, and then we'll transition over to the AP practice. Michael, you're just joining us. I'm sorry, I'm going to have to give you a tardy bud, but we are working on test review questions. We did just grade 2000 and 2002. If you want to open up Google Classroom, the answer key is in there to grade those two that were homework over the weekend. We are trying to bust out as much test review questions, as many test review questions as possible. For number 7, I guess actually if I'm writing, I can just, oh, hi. I can just zoom out. For number 7, they just said to solve the differential equation dy dx is equal to, all right, guys, anytime you see a differential equation, which you are definitely going to see tomorrow on the test, what would I say is your very first step to solving? First of all, is this particular or general? If this is all they've given me, what are they asking me to do if they say solve? General, because they did not give me a there's no clue. Second of all, anytime you see a differential and you're trying to solve, what is the very, 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 very first thing? If there's a y prime, make it dy dx, but otherwise do what first? Multiply. And as soon as you multiply dx to the other side, do I need to rearrange anything? No. What integration rule does this match up with? The integral of e to the u, good, Ryan, is e to the u plus c. I can do that, right? So what do I need to do? U sub. Some of you guys have been looking at your chapter 4b corrections. How do you do u sub? U is equal to the exponent. What do I do next? Du is equal to 0 minus 1, so negative 1 dx. I'm going to plug into my integral, so I solve for dx. And then I end up with the integral of dy, specifically 1 dy, is equal to the integral of e to the u with a negative du. What is the integral of e to the u? Perfect. So is it okay if I go e to the, with a negative in front, plus c, and what's the integral of dy, or the integral of 1 dy? Do I need to do anything else? And the answer is no. Dun, 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 dun. Is that cool? Okay, after number 7, I think we are going to number 19. Why was number 19 a little bit harder? Yeah, there's a lot going on, right? 2 plus x, there's a y prime minus xy equals 0. Gross. Okay, hold on. I said just a second ago, if there's a y prime, what should you do before anything else? Okay, but why can we not multiply by dx right this second? Or maybe we shouldn't multiply by dx this second. Maybe some of you wrote this down and made a note of it. I definitely said it last week. If there is addition or subtraction, what did I tell you to do first? Yeah, move it to the other side. We want one clump on one side, one clump on the other. We don't want this dy dx in like a partial. If we just move the xy to the other side, why is it now good to multiply the dx? Haven't I now established where the dx should go and established where the dy should go? Except that y doesn't belong and that 2 plus x doesn't belong, right? So if I can just divide the 2 plus x on both sides, if I can just divide the y on both sides, do I now have something that is legal for me to tackle? Definitely. Now, does that mean that's an easy integral? Not necessarily. It's a little bit rough, right? However, hold on. 1 over y, we should know that one, right? What's the integral of 1 over y? ln of? Good, absolute value of y. But why? I apologize. Why is this one a little bit nasty? You have some options. What do you guys think of doing? Okay, you could have gone straight for u sub, maybe u equals x plus. I wish we could separate the two fractions as it is, Ryan, but the problem is with denominators, I can't split up denominators. That is the common denominator. I can't split up that. I could split up a numerator. One option is u sub. Did anybody do anything different besides u sub? It is 2 plus x, except, Christina, I didn't like that, so I switched it just because it's legal. But yeah, no, 2 plus x is also good, though. Does anybody see it's an improper fraction? The degree of the top is equal to the degree of the bottom. What can we always do if it's an improper fraction? Divide. So you had options. You could have divided, but it's okay. You could have done u sub, so I'm going to go that way because I guess that's what the only right thing that our brains were thinking. So if u equals, as Christina said, 2 plus x or x plus 2, the only problem is that enough to totally substitute? So what do we have to do? X equals u minus 2. So Ryan, now we're getting to where we can legally do what you said, because we're going to plug in for this x, u minus 2. We're going to plug in for u, and dx is du. I didn't really have to do anything. So I can plug in for that. Now that I have this expression in the numerator, now I can split up. Now it's legal, because this is u over u minus 2 over u. So that would end up equaling u over u, or u to the 1 times u to the negative 1. That'd just be 1 minus 2 over u. You guys okay if I go down to u minus 2 ln of absolute value of u? Is that okay? Okay. Problem is, what do we still have to get alone? Solve the differential equation. I think I need to get y by itself. Now, guys, that's not to say that tomorrow there might not be any multiple choice questions where you are allowed or where they leave it implicitly stated, like with the y all mixed in or mixed up. So you can keep an eye on your multiple choice, think about making it match. But in this one, the back of the book has y by itself, so I'm going to go ahead and plug in. Sorry, this is getting really yucky and gross because I just ran out of room. But u is equal to x plus 2, right? So ln of absolute value of y is equal to x plus 2 minus 2 ln of x plus 2, or 2 plus x. Technically, this 2 and this c can combine to be a new constant, so I'm going to go ahead and move that to be a plus c. X, I'm going to make it plus ln of parenthesis x plus 2 squared. What I did is I moved that 2 up. Sorry, it shouldn't be a plus. It should still be a minus. I moved that 2 up to be a power. And then x plus 2 squared doesn't need an absolute value anymore because the squared makes it always positive. The problem is I still have an ln over here. So guys, how do I get rid of ln? So absolute value of y is equal to this part. I have e to this guy, I have e to that guy, and I have e to this c. That c can come in front. I still have e to the x minus ln of x plus 2 squared. Did they simplify more? I see how they could have. Just in case, this subtraction of powers can be division. So you could have done e to the ln of x plus 2 squared. Do you guys see why I split it up? E to the ln, what can you do? Cross it off. That absolute value for the y can kind of get absorbed into that constant over there, which will sometimes be positive and sometimes be negative, so we can go ahead and get rid of those absolute value bars. And then technically, if I was to write what I have left, I have y equals c e to the x all over x plus 2 squared. In my mind, that's the simplest way of writing it, but there again, the back of the book could have stopped a few different places, I suppose, if it really wanted to. Sorry, guys. Wow, that is a mess, if I ever saw one. Great question on number 19. What else did we have? We had number 19, 23, and 37. Nice thing is 23 is a lot easier as far as the type of question, and number 37 is pretty similar as far as what's going on. 23, it gives you 2 points. This is section 5.2 all the way. And remember, section 5.2 zoomed in on what type of growth and decay? Exponential. So in number 20, when we look at that graph and when we see it says swoop dead, is I know right away, even though they're giving me the points 0 and 3/4, even though in the directions they're giving me the equation, hey, make it fit c e to the kt, I already knew that from the swoop. So then all I need to do is, wait a minute, guys, isn't t your x and y your y? So didn't they give you 2 clues where you can say when y is 3/4, t is 0, and when y is 5, from these clues, t is 5? At this point, I can say 3/4 is equal to c, because anything to the 0 power is 1, and c times 1 is c. Down here, I can say 5 is equal to, well, hold on, if I know what c is, can't I just plug and chug? So 5 is equal to 3/4 e to the 5k. Mathematically speaking, how do we get to k? Can't take ln yet. What do I have to do first to get to the e? Yeah, multiply by 4 over 3. Some of us, our algebra is a little bit shaky. Got to be careful. We have to get that e by itself, so then I can take an ln of both sides. What's that end up being? 23rds? That's awkward. ln of. Now I am allowed to cross off that ln of e. 5k is equal to ln of 23rds. Divide by 5, multiply by 1/5. Got 'em. K is. So once I have k, once I have c, don't I just have to plug it into my equation from the very beginning? So y is equal to 3/4 e to the 1/5 ln of 23rds. Do you guys remember on a test not too long ago where I mentioned that there were going to be motion problems on said test, and some of you did not practice or study the motion notes or the motion examples, and so you were really sad when we got to that part of the test? It was the one we took the test on 2 different days. What do you think is going to be on the test tomorrow? Exponential growth and decay. Can you literally study the types of examples we did from the notes in the homework? Yeah. I mean, practice test is good, of course, but you have tons of examples for exponential growth and decay. Was there examples in the notes, in the homework, of how to do a problem like this? Heck yeah. Okay? Study your notes, study your homework, have it close by. The last question from our test review was number 37. And number 37 was a differential equation. Once again, guys, great questions, great practice. I'm just going to flip this over. What did you guys do in number 37 when you saw y cubed times y prime minus 3x equals 0, and you had a little y of 2 equals 2? Particular or general? What are we aiming for? Particular. What's the very first thing we do? Make y prime dy dx. And then, does anybody remember from just a second ago, maybe you should have a colored pen out and make a note to yourself. was tutoring a college kid in Calc 2 last night. And the way that she studies is she does homework. She gets stuck. She asks me questions. She figures out how to do it right. She color codes her finding her mistakes. She color codes me finding extra mistakes. She writes notes to herself as far as exactly what she had to remember that she forgot, whether algebra or pre-cal or calculus formulas. And then she goes back and does all the problems again. And then she does the test review. And then she does the test review on whiteboards again. Why? That's what her brain needs to do calculus. Some of you need to work harder. But is there a pattern between this question and the last question? Y prime becomes dy dx. What do I tell you to do first? Multiply by dx. But why doesn't that work? Who's in the way? Should you write yourself a note, maybe in a colored pen, saying anytime there's plus or minus, move it to the other side? I've been saying that ever since last week. Some of you, just write it down. Study it. Study the types of problems that might trick you tomorrow. Should you maybe write down in a colored pen what we're doing? Y prime became dy dx. We split it up to two different sides. And then we're going to multiply both sides by dx, like I say to keep doing, right? Multiplying dx to the other side. Oh my goodness, guys. Isn't it gorgeous and ready to go just as is? Don't I have function of y's dy, function of x dx's? Shouldn't I now be able to do power rule? Shouldn't I now be able to do power rule? How do I get y by itself? Come on, you guys know. Multiply both sides by 4. Yeah? We can name this a C1 if you want. 4 times C1 will just be another C, whatever. And then I have 6x squared equals y to the 4th. And we undo a 4th power with a 4th root. Y equals the 4th root of 6x squared plus c. Unlike the book, I decided to get y by itself, then I'm going to plug in. Now technically, when you do an even powered root, technically there should be a plus or minus, but why am I going to make a note of my clue and say y is greater than 0 and come down here and erase the positive and say, ooh, that doesn't make sense. What does y need to be, the positive or the negative square root? Positive. So unlike homework, I'm going to circle the positive and ignore the negative to make it legal for my clue. But after that, I plug in my clue and say y is 2 when x is 2. I'm going to solve. That's going to be 24 plus c. I'm going to do the 4th power of both sides. 2 to the 4th is 16. 16 minus 24 is equal to negative 8. Double check my math. And plugging c into my equation, I get y is equal to the positive 4th root of 6x squared. How's it look, guys? Good. All right, we've gotten through the entire test review. What does that leave us with as far as questions? Page 40. What was different here? Yeah, multiple choice practice. The nice thing is, I mean, in some ways it's nice, in some ways it's bad. You guys want to basically see 1, 2, 3, anything but 4. Not anything, everything but 4, and maybe a few of you want 4 also. But kiddos, as we are looking at number 1, isn't this a slope field matchy question? Slope field matchy question. My question to you is, what are we looking at, slopes or flow? Slopes. Why? Because it says dy dx. Now, is this in terms of just y, so it's going to follow horizontal parallel lines, just x, follow vertical parallel lines, or a little bit of both? Stink. A little bit of both. Okay. So right now, are there any ones that are parallel as far as x lines or y lines? Ooh, I don't see any. Otherwise, we'd be able to kind of like narrow some of those down. All of them are kind of changing. Now, we did talk about at one point about how, excuse me, if there was adding or subtracting, they would follow diagonal lines. The problem is we have this little nasty 1/5 guy going on. The 1/5 guy makes things a little bit more complicated. Okay, let's get rid of some of that light. So if worse comes to worse, let's see what's going on. I see a flat line way over here, which is kind of awkward. It's like negative 5, 1. I wonder if, see that little flat line? Why did my brain zoom in on flat line? Flat lines only happen when the slope, when the dy dx equals what? 0. So why don't we plug in negative 5, 1 and be like, let's see what happens. Negative 5 over 5 would be negative 1. A negative negative is a positive 1. What's 1 plus 1? 2. It's not A. If it was A, it should be sloped up like that. Where does this guy have a flat line? Here. 5, 1. Does that make a difference? 5 over 5 is 1. 1 minus 1 is 0. Ooh, he could be. Does he have a flat line? Nope, not him. Does he have a flat line? Nope. B's the right one. Guys, I haven't seen this question. I don't even think we went over it last year. What did I do? I said, oh, stink. They all have tons of positives and tons of positives and tons. Ooh, I guess I could have plugged in. This guy has negatives. I could have plugged in the second quadrant. A negative x with a positive y. A negative x would be a plus, and a plus and a plus. Oh, it can't be him. He's sloped down second quadrant. That says they should all be sloped up. Can't be him either. I could have crossed off these guys just by looking at all these negative slopes and saying they're impossible. There are many different ways, but the first thing your brain has to do is ask yourself, am I looking at slopes? Looking at flows. Number 2, you guys had a question on. Number 2 says a population P grows according to the equation. Isn't that a differential equation, guys? Who's your y? P, and who's your x? T. So what do you think my advice is going to be as far as how to start with this differential equation? Multiply both sides by dt. If you multiply both sides by dt, you'll end up with dp is equal to k times p times dt. Who doesn't belong? P. He's like the y value. Oh, it's mad. Okay, it's getting happy. Oh, nope, it's mad again. We'll see if he gets happier again. But we're going to go ahead and divide by p to get him over with the dp. Who's k whenever you see him? Is he a variable or a constant? Okay, so it's not that bad because I'm going to end up with ln of y is equal to kt plus c. Oh my goodness, this is exponential growth. C e to the kt. I should have maybe realized that sooner. Oh well, whatever. I know it's exponential growth, and then what's the clue they give me? If the population triples every 15 years. Triples, isn't that a ratio? And don't we have a yellow card in section 5.2 that I didn't make you study for like a forever quiz for the AP, but I did say it was important, where we can make a ratio of how much we have versus how much we started with. Triples, doesn't that mean the ratio is 3? Doubles would be 2. Half-life would be 1/2. It's us dividing y by c, or y by y sub naught. However you look at it, you're going to just have the e to the k times t. And guys, how much time does it take to triple? 15 years. So all I have to do, and some of you need to make a note of this, star that yellow box and be like, that's right. If they tell me a ratio like triples or doubles or half-life, I can rearrange my equation and say that this division, which equals e to the kt, is that ratio. Because at this point, all I need to do is do ln of 3 to get 15k, 1 over 15 ln of 3. And not that it's necessarily super helpful for the AP, but for this test it might be. In general, k is going to equal 1 over the time that it takes to ln of ratio. In chemistry, this is something that you would do in the sense of the half-life. Ln of a half, 1 over the time it takes. Doubling, ln of 2 over 1 over the time that it takes. Tripling, ln of 3, 1 over the time that it takes. To be honest, you can kind of memorize that if you want to for tomorrow. But long story short, I do believe letter B is the right answer. Number 3. If you guys notice, number 3 is also exponential growth and decay because our y prime is ky, just like kp up here. They give us 2 clues. Hey guys, didn't we just see an example just a moment ago where with 2 clues we can solve for our exponential growth or decay? So guess what you're going to do in number 3? Same thing. Y equals C e to the kt. Plug in your 2 clues and you can solve. You guys didn't need number 4. Number 5, you had a question too? Oh, come on. What's my advice? You didn't even have to add or subtract. My advice, what do you do to both sides? Multiply the dx, and as soon as you multiply the dx, dy equals 3y over x dx. Don't I just need to get rid of my y? So I can get rid of my y by moving him to the other side, and all of a sudden my life is so much better, and I'm good to integrate and get to pretty quickly ln's. Guys, what's a cool thing that we can always do with ln's when we have numbers in front? Make it an exponent. So I can say ln of x. You can put the cubed inside or outside. It doesn't really matter. I just need the absolute value because it's odd. But as soon as I've gotten rid of that puppy, now it's algebraically legal for me to go ahead and multiply. Whoa, whoa, whoa. Where's the plus c? Is it addition on the outside or is it in the exponent? And if it's in the exponent, what's it going to become? Multiplication. C times. Because I can change this plus c to be times e to the c. Now that I have that separated, e to the ln cancels out, so I have x cubed, and over here I have absolute value of y, which will get absorbed into the c. Something like that, and oh, they give me a point. So once you have that, plug in your x, y, solve for your c, and booyah, you'll have it. It's not going to be him. There's no plus or minus. It's not going to be him. It's either him or him. And if y of 1 equals negative 1, I'm pretty sure it's b. Number 6. Am I looking at slopes or following the flow, cool kids? Slopes. Hey, do you see flat lines? I see flat lines. I see flat lines when y equals 3. Flat lines when y equals 3. There's a number. Forget him. 1 minus 1. Well, that's a bummer. I only crossed off 1. You went from 5% to having 1. But what else do I see? I see some negatives up here. I wonder if that makes a difference. I see some positives like almost everywhere else. I see some negatives over here too. That slope down, that slope down. In essence, you can kind of start plugging in points. Like when y equals, I don't know, negative 3, positive 4. Negative 3, positive 4. There are no x's, so I guess you're just plugging in positive 4. 1 minus 4/3 would be a negative times a positive. Okay, that works. 1 minus 4/3. 1 minus 4/3. Ah, stink. Those are all going to be negative. Let's try this one. When y equals negative 1, negative. If y equals negative 1, wait, no, that's a, well, that'd be a negative. If y equals negative 1, that'd be a negative. If y equals negative 1, that'd be a negative. Aren't those like way different as far as their slopes? So what if I was just to plug in like when y equals 1, and these are super, super, super steep. 1 minus 1/3 would be 2/3, times 1/2 would be 2/6 would be 1/3. Does this look like 1/3 up 1 over 3? No, he's way too small. Okay, so now we're looking at these ones. So this one would be 1 minus 1/3 would be 2/3 times 1, 2/3. Does this look like up 2 over 3? I don't think so. 1 minus 1/3 is 2/3. 2/3 times 10 would be 20/3, which would be 6-ish. Does this look like 1, 2, 3, 4, 5, 6-ish? And it's better. Yeah, I would go A just because of how steep everything is. Tricky, but not impossible. Kiddos, the last one that you guys were asking me about was number 9, right? Because I don't think I went through 6 and then number 9. Okay. So number 9 was the last one. Does this look like a free response-ish type question? Yeah? What's the first thing I would tell you to do? Well, okay. It actually doesn't tell you to solve, does it? Not until letter C. Letter A just says find the second derivative. Do we remember how to find second derivatives given first derivatives? That was important in the FRQ we saw a second ago, right? Don't we have to go ahead and take a derivative and then derive it? How would I derive this guy? Well, derivative of this guy, right, if I do d dx of the whole thing, derivative of that guy is the second derivative, right, guys? How do I derive quotient rule? Can't I do bottom d top minus top d? Why am I doing parentheses and a plus before doing bottom squared? Who is this guy? Isn't it a product? And doesn't product rule require me to do second d first plus first d second? So I then go ahead and simplify and say, okay, whatever, that guy is 0. This guy is going to end up being distributing the negative. I have negative y minus x. What on earth am I going to do with dy dx, guys? What did I do anytime I had implicit differentiation? Who is dy dx? 1 over x, y, right? And I could go ahead and simplify if I wanted to. I can make it a little bit nicer, a little bit easier. But long story short, I can multiply with my trick to get rid of my complex fraction. I would end up with negative y squared minus 1 all over x squared y cubed. They didn't actually ask me to get a pretty equation for the second derivative. I think they told me to find the second derivative at a point. So you could have plugged in that point actually up here. You could have plugged in that point here or here or here. But long story short, they wanted me to plug in the point of 1, 2. Because I think they want me to figure out the concavity. 1 squared times 2 cubed, which would equal negative 5 over 8. If my second derivative is negative, what does that mean about my concavity? Isn't it concave down like a frown? What else did they say? Write an equation of a tangent line. Oh my goodness. Now they're asking me to do a tangent line? It's like I have to go back and remember y minus y1 equals m times x minus x1. But guys, didn't we have tangent lines in the slope field worksheet that we had to review? And then what did the last part ask us to do? And then we would plug in. What did letter C ask us to do? That's where you would want to go ahead and multiply by dx. And when you multiply by dx, who doesn't belong? So I multiply by the y. Yep, you guys can be packing up. What's going on tomorrow? Do you guys need to study your slope field worksheet? Yeah, a lot of these topics are on the slope field worksheet. Do you want to play with the practice test, the answer keys online? Yeah, it's a good idea. But do you need to study your notes and examples? Yeah. But are there patterns? Oh, come on, there are tons of them. Find those patterns, study those patterns tonight. Get out of here, cool kids. Wait, it's a test tomorrow, so what time are you coming in? I'll see you guys later. Those contents, don't let me take your homework. Grade it. Don't let me take. Get those points, as many as you can. I need to close this down and see why it's not working.